Hello everyone and welcome to this primer video on tools that we use in systems programming. So we'll be going over just some of the basic ones pretty quickly, and hopefully this will help you understand the things that we'll be using in this class. So first of all, how do we connect to the data server? Most of the work we do on this class is on data. It is very important to do things like compiling your code there, because usually that is going to be backed up on the Git so we can see your progress throughout the project. So first of all, we have our Unix option. This is going to work well for if your local machine is Linux or a Mac. You can just simply use the SSH command, supply a username and a host name. It will ask for your password, and you'll be good to go. If for some reason you need to specify a port, you can. You'll have to use the -p option. With that said, you probably won't have to, because the default 22 is going to work on all of our computer science machines at Purdue. And this is the command you'll be using most of the time, is just SSH your Purdue login at data.cs.purdue.edu. So that's good. But what if we're on Windows? Well, we can always use like WSL or something like that to pretend we're on Linux, basically. But a quick solution is to use PuTTY. Now, PuTTY is an ancient program. This thing's been around for a long time. But I'd like to show it a little bit here. So this is PuTTY when I've already logged in. In fact, we'll show so you can see what it looks like. This is PuTTY when you just started out. You can specify the port. It can actually do a couple different types of connections, but just make sure it's on SSH. You can put in your host name, that'd be data. You can even put in the username. Example, I have in a saved session down here, Jacobs57, my username at data.cs.purdue.edu. So that's good. This one's already logged in though, and then we can, ls, we can cd. Also note, you can actually copy and paste with this pretty easily. So the way you're going to do this though is you're not going to Control-C, because that will obviously just kill whatever program, or in case of a bash editor, just make it tell you it won't work. You can actually highlight, and this highlighting is actually copying. So if I take that and then go back here and Control-V, all that is copied over nicely. So, and you can also paste into this. In this case, I'm going to Control-C, go over here, and I'm going to right click, and there we go. So yeah, that's how you use PuTTY. It's pretty simple, not too difficult to use. Didn't like me doing that, and that didn't like me doing that. But yeah, PuTTY, I suggest if you're on Windows, you should download it. It makes life easier. Now, how about file management? Of course, we can just use SCP, but using SCP is a pain, and you got to keep everything synchronized, and I don't want to deal with it. So what we're going to do is use a remote file manager of some sort. Now, a lot of file explorers actually come with this installed. Especially on Linux, you can find file explorers that have this functionality to remotely mount a drive or remotely mount a part of the remote file system. And that's really good, and if you have that available, that's fine. Also for Linux, you have FileZilla. Oh, this will actually work for anything. This will be Linux, Mac, Windows, anything. FileZilla is nice, but I found that it doesn't really have the features that I want at all times. So if you're on Windows, you have a great piece of software here available called WinSCP. WinSCP is awesome. Let's take a look at that. So in this case, I have all these little saved sessions over here. This one actually I don't even have to log in because while it doesn't actually have this password here, it does have my my machine's keys are saved in the in a Linux key thing, so it'll automatically recognize this machine. So log in, it'll do that. And there we go. So on this side, we have our Linux machine. This is on data. I have a remote directory and a local directory. And we can do a lot with this. So we can easily go over here and like edit one of these files directly. So say I want to look at this regex guy here. I can open it, and here it is in my editor. And I can edit it here. And if I edit it here, it will actually be edited across in the local machine. All it's doing is it's got a temporary file that it's storing somewhere else on the file system, app data it looks like. And it is then synchronizing that with our copy data. So that's good. That's a good thing to have. The other thing we can do, though, is we can get all these to match. So in this case, I want to get this to update all of these. So I'll drag it over. Most of these are going to be overwrites, so I'll just go newer only. So there we go. You can put code on data that way, or you can take code from data and put it on your local machine. And the other thing you can do is actually keep these things synchronized. Actually, first I want to show you real quick. This button right here also just opens PuTTY to whatever server you're connected to. Then you'd have to put your password in, and you can handle everything that way. I'm not going to do that, though. What I am going to do is show you that we can synchronize these. So I'm going to press start here. And yeah, full synchronization at the start just to make sure everything's right. So now it is watching what happens on this directory. Or I don't think the other way around. It might be. Yeah, it is the other way around too. It's so if anything happens over here, it will be synchronized to here, and vice versa. It won't delete files just because actually it will delete files. Yeah, I suggest clicking that box, but just to make sure it doesn't delete things that you don't want deleted. But what this is going to do is just keep these two directories and all subdirectories inside synchronized for us. This is really good. This is a really useful thing because now what I can do is minimize this, and in my editor, edit whatever I want on my local directory and be fairly certain that it's going to be copied over correctly to our remote directory. And that includes things like line endings. So it should, I've had it not on certain types of files, but it should convert all of our Windows new lines over to Linux new lines, which is very good. All right, so that's remote file management. Next, I want to talk about editors a little bit. So first of all, let's assume that we're working with just things we want to handle remotely. We don't want to do any sort of remote file management or anything like that. Then we have two main options here. So let me stop this, close that, do this. I'm going to type my password. see it anyways. So first of all, Nano. Nano is a very, very, very simple text editing tool. It does not have a lot of bells and whistles. It's going to look like this. We can type some stuff. We delete new line. Not much else. It has a few options spelled out here at the bottom, including exiting, saving. This write out is saving, by the way. We're going to exit. That's, by the way, the up thing is control, so it's for exit is control X. It's going to ask if we want to save. I'm going to say no, and we're out of Nano. Nano is really good for like editing config files or debugging little things. Really, it probably isn't suited for writing your whole code. It's just doesn't have enough features to be helpful. But it's good. It's an important tool. The other command line editor that I'm sure you've worked with at some point in Purdue so far is Vim. So Vim is annoying, but really powerful. The main thing that people always get hung up on, of course, is quitting. That's going to be colon to put us down here in our little command box, and then Q, and then enter. But Vim has a lot of really useful tools. I won't be going over them today, but Vim has a lot of options as far as text editing to make it pretty fast. It's a powerful little tool, and it's probably worth getting to know at least a little bit. But it can definitely, if you like GUI-based systems more, I would try to stick to a GUI-based system, though at least learn the basics of Vim. And if you have some trouble with that as well, have here a few options to look at. The Vim Adventures especially is fun because it's actually a little game that teaches you how to use Vim as you play it. If you prefer just a text-based guide, there's one here. And you can see some of the tricks that you can learn with Vim to make life easier. So yeah, that's Vim. I personally pretty much never use it. Now we have VS Code. This has gotten really big in the past year, I think, of people using this anyways in class. This is a full-fledged IDE. It has a lot of really useful capabilities. I don't have it installed, and if you like the full IDE thing, the very heavyweight sort of system, VS Code is a pretty good option for you. There's one thing I will note on VS Code, though. There's something called file descriptors. We'll talk about them in XS later, and in the class you'll be hearing a lot about them. But these are basically, think of them almost like pointers, but to things in the file system that are open. These things need to be opened and closed manually. And as you create new processes, the open file descriptors of the parent will be given to the child process. Now, this is important because VS Code, when you're running its SSH program, it actually opens a bunch of file descriptors that it doesn't later close. And in certain projects down the line, we will be checking for open file descriptors. We'll be going in afterwards and seeing if you have any open file descriptors left that we might need to take a look at. And it can be part of grading, making sure to close all your file descriptors. So make sure if you are using VS Code and we are checking for open file descriptors, then use PuTTY or something else to SSH in. Just because the VS Code's SSH is not going to clean those up and will accidentally end up detecting those, and that's a dumb way to lose points. So yeah, VS Code is good, just be careful with the file descriptors. Last one I want to talk about is what we're using today, which is Atom. I love Atom. I'm very biased with this one because this is a great, really useful little text editor. Um, very extensible. This is an open source project. I would say the only thing I really don't like about Atom is that it doesn't handle really big files well. So if you've got a giant CSV data set or something that you're trying to open, it's going to try to load the whole thing in and it's going to be really slow and not good. That's the only big problem I've had with Atom over the years. Other than that, it's really useful. You can add all sorts of different packages to it. I've got a bunch here. You've got a bunch of very sophisticated finding features involved, finding and replacing. Same with selection. It's got a project viewer here. It's decided to open notes as being the project, which is not quite correct, but that's fine because I didn't open one on my own. I usually just have it open to my main code directory, and then I can just look through everything. I also have one of these in. I like these. You can, especially if you have, in this class, something like this is really good because we have really long code, and it's really nice to be able to just scroll around and see where everything is. But yeah, Atom's great. Highly recommend. And there's other options out there that I'm not going to talk too much about. Notepad++ has been used. Sublime is basically Atom, but you have to pay for it. There's other options. There's one important thing when choosing your editors, though. Know your editor well. And I say this because in this class, the TAs and all of us who are trying to help you through the class, we don't know all of these editors. It'd be pretty inefficient for us to put a lot of time towards learning every single possible editor and any new ones that come out. So we don't. We usually just know one editor, maybe two. So a lot of the responsibility for that is going to be on you guys to know how your editor works. And if we are helping you debug something and we say, all right, can you go search for this in your code or save and exit and go do this? You need to know how to do that because we're not going to be able to help you some of the time. Obviously, if you're in Nano and you're stuck, we can help you out, but it's not always we're not going to know all of the functions of every editor. So make sure you know what's going on. Google around to figure out tutorials on it. Or if you're really stuck on something, you can even post on Piazza, hey, if there's anyone who knows this editor, I'd like to ask a few questions, and I'm sure someone will be happy to answer. All right, so editors, good stuff. And the last thing I want to talk about in this quick video is the compiling tools. So there are three we're going to look at: GCC, G++, and Make. For this, let's take a look at a Make file. Specifically, let's do the recursion example one. I think that one was, actually, no, that one wasn't as good. I think the systems one, yeah, there we go. So, Makefile, usually going to be capital M, no space, no capital F. This is just a file that is going to contain this little script that tells us how to compile our program. And then when we type make into our shell, it's going to compile, it's going to run this script basically. Now, the way to read these, we have up here all. This is our main directive. It's going to tell us that we want to do this, and this involves accomplishing certain subdirectives. You can think of these as subdirectives or as requirements. But for all to be done, we need to run systems. So our systems directive down here is then dependent on the systems main.cpp. So this is going to consider itself to be done unless this changes. So if you type make once after editing systems main, it's going to compile. It's going to run this little sequence of commands. If you run it again without changing the system's main in between, it's going to say something like all objectives completed or something like that. And it won't recompile because it doesn't need to. It already did the ones. So yeah, just if you're trying to like look at something again or look at a warning again or something, just change the file a bit. Here we have G++. It's just GCC, but for C++. We'll be using both in this class, C and C++, at different labs. This flag is important. You'll see this a lot, and I would add this. If you don't see it in a project, add it. It is incredibly important because what this does is adds the debugging symbols into your compiled code, which means that you can use a debugger like a GDB to look through your code and see what's going on inside of it, which that will be covered more in the debugging video. But yeah, GDB will not work without something like this in your compile flags. We have -O. This is saying what we want to name our output. In this case, just systems main. We have finally the name of the file we're compiling. So if you want to think of this in units, we have this, which is just one single flag, this, which is a flag combined with a argument that corresponds to it, and then finally systems main.cpp. That is going to then, that's the code we're compiling. Also, we have this here. This is not going to be in all of your code, but this is a flag saying that we want to use the pthread library. Because this systems main program we wrote is actually using threads. So just make sure if you're using threads, you have to include this. Otherwise, it won't work. There's a few other libraries that need something like this, but we don't need to worry about those too much. And yeah, this will compile our program, and then it will tell us that it compiled our program. So that's basically what a makefile is. In this class, they'll usually be a little more complicated than this. They'll usually have like a variable that's going to be holding all of the arguments all the flags we're using for compilation. So you'll see that in there. You'll also see a git commit and a git push a lot of the time. So what this is going to do is commit to the git repo that your project is attached to, and then push to our remote repo for that. Again, this is very necessary for grading, so make sure to not touch those. Don't mess with those commands, just leave them be where they are. In some projects, there'll be a version of make that we have available, so a certain input you can put in that'll say that will allow you to make without doing that push. And there's a few reasons for that, but again, you should not be doing that for just compiling, because we're looking at how many, for part of our way that we detect academic dishonesty is by looking at how many commits you've done, what times they were done, things like that. So you want to leave that data as pure as it can be, and make sure to keep that commits going. Sometimes you'll also see another one where you can put in something like make clean, and what that'll do is clean up all of your compiled binaries. So it won't delete any of your source code, but it'll delete your compiled code. And that's about it for make files and compiling, and I think that's about it for our whole video here. Um, I hope you enjoyed it, and we'll see you in the next one. Peace.